So rate of change is maybe not a term that a lot of people heard in this course. By definition, it's if we have a given function f of x and we have the interval that it's on, usually it's an x interval from a to b, or it could be from like 2 to 5, for example. We find the average rate of change by plugging in b to our function, subtracting it from if we plugged in a into our function and took that result, and then all over b minus a. Now, we call it average rate of change more often than not when we're talking about applied word problems, stuff like that. But actually what this is more commonly known as is slope. It's just a really weird way to kind of look at the slope formula, but for those who know the slope formula, typically we go rise over run, or if you're feeling particularly fancy, y2 minus y1 over x2 minus x1. Well, at top, that's y2. F of b is y2, f of a is y1, and then the bottom is just your change in x. So that's really what average rate of change is its slope. So to see that in practice when we're dealing with a function like this, I want to find the average rate of change of f of x from -2 to 5. Well, I would plug in -2, I would plug in 5, and I would get that result. So I kind of did that all at once, but to break it down on the fraction. The top left of the fraction is, if I plugged in 5 into my function, there's a 5 now in the denominator. The very top right of my really big fraction is if I plugged in -2 into my function, and then the bottom of my average rate of change is just my 5 minus a -2. So then there you kind of just have to simplify all the way through. Ideally, you're going to be left with just a single fraction or maybe even a whole number. So 5 plus 3 gets me 8, -2 plus 3 gets me 3, and so the top becomes 3/8 minus 3 over 1, all over 7, 5 minus -2. If I subtract the fractions on top after getting a common denominator, I get -21 over 8. And then if I'm dividing my fractions, that 7 becomes 1 over 7, multiply straight across. That's equal to -21 over 56. And not to kind of get lost in the noise of all of that, because there was a lot of fractions, but all I really did was find my f of b, find my f of a, plugged it into my average rate of change formula, and then simplified. It's just, unfortunately, with this example, the simplification was a little bit tricky because I had to subtract fractions and then divide fractions and multiply fractions. But that's the idea. And then, as always in this course, if you have a fraction and you can reduce it, reduce it. So that's exactly what I did in that final step. So to see it again, here we have a function f of x is equal to 2x squared plus x plus 3, and now I have a little bit weird of an interval, 0 to c, but that's perfectly fine. Quite often when we're dealing with average rate of change, we don't have a nice number, whole number, or even a nice fraction with numbers in it. Sometimes we have variables. But I'm still going to use that average rate of change formula that we saw in the last slide. I'm going to plug in c into that function. I'm going to plug in 0 in my function. I'm going to subtract those on the top of my fraction, and then I'm going to subtract my interval on the bottom of the fraction, so c minus 0. And now I kind of more explicitly did it in individual steps for this problem. So I found my f of c, since it's kind of weird with the squared and the variables. That all I did was plug in c into my function. So I get this result, f of c is equal to 2c squared plus c plus 3. And f of 0, that's pretty easy to find. I plug in 0 everywhere there's an x in my function. I'm left with 3. 2 times 0 plus 3 is 3. So now I have all of my pieces to find my average rate of change. I have my f of c, I have my f of 0, and then I have my given interval. So I'm just going to plug those two things into my fraction. I'm going to subtract. And then I'm left with 2c squared plus c over c. Now, since both of those terms on the numerator of the fraction have a c in it, I can actually divide both parts by c, and I'm left with, well, 2c squared divided by c is 2c, and c divided by c is 1, so I'm left with 2c plus 1. Now, if one of those terms didn't have a c in it, I couldn't kind of do this nice simplification that I did all in one step, but in this case, I have c's in both terms, so I'm allowed to do that. Something worth mentioning that I guess maybe we'll see later on in the slides. If I have more than one term in my second, like my f of 0 or something, it's a good idea to put a parentheses around it so that when you're subtracting, you're actually subtracting properly and you'll have to distribute the negative. Hopefully we have an example of that in the near future. Now, finding average rate of change for a graph. In this case, I actually am not given a function. I'm just given a graph, and it's actually just a bunch of points, but that's perfectly fine. We see that with a lot of examples in the real world. And I want to find the average rate of change from 1 to 4. Well, on this graph, probably should have been labeled, but if it's not labeled, we assume that's an XY graph. And so my coordinate of 1 would be just 1 to the right of the origin, and then, well, it's going to be up 2. So my value of f of 1 is equal to 2, and my value of f of 4, as I just circled, is going to be, let's see, 1, 2, 3, 4, 5 from the bottom. So using that formula, I'm going to try and find f of 4. I'm going to find f of 1. Well, I already found them. I'm going to plug them into my formula. I'm going to subtract it from I'm going to divide by the interval I subtracted over. So as I mentioned, f of 4 is, counting from the bottom, 1, 2, 3, 4, 5 up. F of 1 is, counting from the bottom, 1, 2 up. Those are the 2 points. And notice I actually don't care about the other points. If I'm finding the average rate of change and I'm going for an interval, I'm looking at just the endpoints, just the value of the whatever you plug in on the left side of the interval and just the value of whatever you plug in for the right side of the interval. And so I probably should have found it, but it's pretty findable. I should subtract this and simplify it. I didn't do that on my slide for some reason. But I get 5 minus 2 is 3, 4 minus 1 is 3, and I would be left with the result of 3 divided by 3 is equal to 1. Which makes sense. If you were to draw a line connecting those 2 points that I circled, that slope would have a slope of 1. It'd be up 1 over 1, up 1 over 1, up 1 over 1, and then we would get the slope of a line that connects both of those points. So I apologize, I made a mistake. That answer should not be boxed. The correct answer for this slide is 1. Average rate of change is 1 for those 2 points.